All right, for this demo, I've created a small project and I call it array demo or something like that. It's got a list box that I called list display that we're going to use to display output. And we have a go button. Very similar to what I usually do. I'm going to double click my go button and we'll write some code in here. First of all, let's declare an array. I am going to declare an array and I'm going to give it a size, but I am going to use a variable. Actually, I'm not going to use a variable. I'm going to use a constant. I say I'm doing a variable while I create a constant. So constants, remember, we capitalize the names of constants, named constants. If there's multiple words, we put underscores between the words. This one's not going to have multiple words. This is going to store the size of my array, and I'm going to make my array 5 elements long. So each item in an array is called an element. And we address the elements by using their index numbers. The index numbers I use the word index number a lot. They are also called subscripts. Okay, and you'll hear me actually use the word sub when I talk about them a lot. So subscript index numbers, they kind of get used interchangeably. Subscript's probably the more accurate term. So let's create an array, just like I showed you in the last video. So I'm going to call this numbers array. It's going to hold ints, and I immediately forgot that it's going to be an array, so I have to use square braces here. Equals new int, and I could put 5 here, but instead I'm going to use my constant that I set up, because if I decide to change the size of my array, if I decide to change the size, it's right at the top of my code. I can find it easily. All right, so let's use some subscripts and set some initial values. So we're going to initialize our array. So I can say numbers array sub 0. Okay, so I'm using the subscript 0 to talk about the first item because it uses 0 numbering just like everything else in programming does. Okay, so numbers array sub 0 is how I would read that. And I'm going to set that value to 5. Numbers array sub 1. I'll set that value to 10. Numbers array sub 2. I'll set that value to 15. And we'll just keep doing this. Not for long. We only got a couple left. Numbers array sub 3. So get used to reading those that way. That's if you're communicating with somebody, even though I often call it an index number, and we use the variable I when we use a loop to loop through those index numbers. When I actually say numbers array, I use the shortened version of subscript, and I say sub 3, sub 4, sub 1. Array sub 4 equals 25. Numbers array sub 5 equals 30. Looks good, right? No errors. Everything works. What's the problem? Hopefully you already see the problem. And notice it doesn't get an underline, but I have 6 numbers in my array that I sized at 5. 1, 2, 3, 4, 5, 6. Okay, so if I run this, I get it as soon as I push the button and it executes this code. It immediately says, hey, index out of range exception. So index, meaning the index number, is out of range. When we create something, an array of size 5, they're going to be numbered from 0 to 1 less than the size, in this case 4. Okay, so there is no subscript 5 in the numbers array. The index number is out of range. Okay, so when you see that, that means you went over. Okay, that means you tried to use something bigger than the size of the array that you declared. Now, it would be nice if our arrays could grow, but they can't. And there's a reason they can't. If you think back to when we declared them, remember I told you that they declare, if I'm declaring 5 ints, it's going to be 5 spots of memory, 32 bits long each, and it declares them all in one big chunk, and it finds the elements by just going 32 bits down the line for each different element. We can't make an array grow because the memory after that chunk may already be used by something else. So we can't just add another one on the end of it, or we may be overwriting data from something else. So that's why arrays have a limit and they can't grow in size, because when we initialize them, we set the size, we set aside the memory, the next memory locations after it can get used by the compiler on the computer for anything else that it wants to use them for. We don't have any guarantee they're not already being used, so we can't let the array grow. Later on, we'll look at lists, and lists can grow, and we'll see why when we talk about how they get stored. So, little demo of things that can go wrong there. So I declared this array one line at a time, very inefficiently. What would be another way to declare this array better? Well, actually, let's process this array first. So we like to process arrays with loops. So I'm going to set up a for loop that's going to count, and I use I for the index number. That's one of the few times in programming that we actually use single letter in variable names, is when we're doing a loop, and it's usually I. If we have another loop, we might use J. Okay, so int I equals 0. Okay, we initialized our counter variable, and we are going to count as long as I is less than the size of our array. And each time we're going to increment I by 1. Okay, so those are the three things. We have to initialize the counter. We have to have a condition that will make the loop end at some point. And we have to have something that changes the thing that we're testing. In this case, we're incrementing by 1. So eventually, it will get bigger than the size, and our loop will end. What do we want to do inside our loop? Well, for this one, let's do list display dot items, and we'll add numbers array sub I. So this variable that's going to count, it's going to start at 0 each time through the loop. First, it's going to do element 0, which is 5. Then the next time through the loop, it'll get bigger and do element 1, which is 10, element 2, which is 15, until it gets up 4, and it does 25. And then the next time around, I becomes 5, which is not less than the size. It's equal to the size, and our loop won't execute again. It will come down here and execute our last line of code that follows it. In which I'm going to say done. Let's run this, and we'll hit go. And you see it says 5, 10, 15, 20, 25, done. Great. That works well. So we can use a for loop with index numbers. And every time I do it, it runs it again. a for loop with index numbers to process an array. Let's go back and declare. This is a very efficient way to declare our array. Let's do it a different way. We can do this, and we can also do, instead of doing these, I'm going to use braces up here, and I'm going to do 5, 10, 15, 20, 25. Okay. So I can fill in the elements of my array when I declare it by using curly braces. So that's a nice quick way. If our loop isn't very big, we can do this. And if I run it, you'll see we get the exact same thing. 5, 10, 15, 20, 25. So that's a little more efficient. As a matter of fact, I don't even have to use the size when I declare the array that size, because it will figure out the size of my array by how many elements I have here. So I could leave out the size when I do that, and it works just fine. I'm going to go back and, I used 5 there. Anytime you see hard-coded values in your code, ask yourself, should I be using a variable or a constant there? Let's initialize our array slightly differently. Let's use a for loop. Matter of fact, I'm just going to copy this loop. Why can I use I again? Because I was declared for this for loop. So each one of these i's has a different scope. This I is for this for loop. This I down here is for that for loop. Remember, after the brace ends for this section of code where that int was declared, it no longer exists. And when we do this declaration for I, it's a brand new item. So same kind of loop that I use down here. Let's do it mathematically, initialize our array. Let's do numbers array sub I equals 5 times the index number. Should give us the same thing, right? Or will it? Run it again. Oh, now we get 0, 5, 10, 15, 20. That's not what we had before. Remember, we started numbering at 0. 0 times 5 is 0. It is not 5. So how can I fix that? Let's multiply them together and then add 5. So now I'm using math in a loop to initialize my array. If I was doing 400 of these, it's way more efficient than the other methods I showed you. Using the curly braces, type in the 400 numbers in. That, if there's a pattern and we can use a loop to initialize our array, that's perfectly valid. If it's a small array, we use the curly braces. All right, so we can use for loops to process our array. We can also, rather than use size, let's change this now. I want to do something different here. I'm not going to use size because I told you that I can do this. And I can do, let's do 6, 9, 12, 15, 18, 21. I declared my array like this, okay, but I never set the size. I can still use the length of the array. So there's a property of an array called length, and we can use that property to set our loops. And it's much better because if I extend this array out now, the length will automatically grow. And let me run it again. And you see it works just fine. So we can use the length array in there. And I want to do another kind of loop as well. Instead of doing this for loop using index numbers, let's do a for each loop. I'm going through these a little quickly because we've covered them in Java before, and it shouldn't be too new to you. All right, so let's change this. Instead of using index numbers, let's use a for each loop. So for each loop looks like this. It uses for each, but we don't use index numbers and we don't count. Okay, so this isn't going to be valid as either. The question is, what are we going to put in there? Okay, so for each, I'm going to call it temp num, just because it helps make this concept a little bit clear. In numbers array. So what does this say? For each number, and I'm calling it temp num for a reason because I want you to see something. For each number in numbers array, I'm going to run some code. In this case, I'm going to add the temp num. Okay, so this variable does not count. This variable holds the first value in the array, and then the second time through the loop, so it'll hold a 3 the first time, and then temp num will hold a 6, and then temp num will hold a 9, and then temp num will hold a 12. Okay, so now we can't use index numbers in a for each loop, but a for each loop is a little bit quicker and a little bit shorter and a little bit easier to read, as long as we're only displaying things or using them in some way. What we can't do in a for each loop is set something to a new value because we don't have an index number. If I wanted to set item 3, if I wanted to set each item to a different value, I don't have an index number to use in here to get the correct subscript to set the values. But it's a nice way to read the values. Let's run this again and we'll see it works just fine. Let's do that with the debugging and then we'll stop this video here. So I'm going to start this, hit go, and here's our loop. And we're going to step through our loop. It's evaluating the for each part. Okay. Now if we look, temp num is set to 3. That's the first number, right? So temp num temporarily becomes 3. And we add it to our list. Okay. Now it repeats. And if we look down here, temp num is now set to 6, which is the second number. Or we can hover over and see temp num is 6. We can keep clicking the button to step through. Temp num is now 9. Okay, so the value in the loop this time is a temporary variable that holds each of the values from the array temporarily while the loop is running. Now, you don't normally see it written this way. If I have an array called numbers, it's plural because an array holds more than one, right? We often see this. You often see code written like this because it's really easy to read. Okay. For each number in numbers, the plural is the array. The temp variable is the singular. So for each number in my numbers, or each number in numbers, add the number to the display or do something with the number. Okay, so that's nice, easy to read, self-documenting code using a for each loop. We will stop this video here, and in the next video we'll look at using an array in conjunction with a file.